So let's continue 1.4.2 box plot. Okay, how you want to describe and summarize your data using graphy. So the first one is box plot. So what is box plot? So you need to understand what is box plot. So we have here box plot is a box and whisker plot. So you must have box and whisker. So it is a graphical method in displaying your data. So graphical. The graphical is the box and the whisker. A box and whisker plot can provide additional detail while allowing multiple sets of data to be displayed. So we want to display our data graphically. Okay, so graphically we will use box plot. Right, so box plot, it is very effective and easy to read, as they can summarize data from multiple sources and display results in graph. So, comparison of data from different categories for easier, more effective in decision making. Right, so let's look at what is box plot look like. So box plot will look like this. So box plot from box and whiskers are a graphical representation of 5-number summary. So you have the 5-number summary. So what are the 5-number summaries? So you will have here 5-number summaries. Number 1, the first one is minimum values. Lowest values means that the smallest data value in your data set. Okay, number 2, here is Q1, first quartile. Okay, number 3 is Q2, the median. And then number 4 is Q3, third quartile. And number 5 is the highest value, your largest data. So we want to summarize, we want to display this 5-number summary through box plot. Your minimum value, Q1, Q2, Q3 and maximum value. Okay, if you look here, box plot, there are 2 types. First is vertical and the other one is horizontal. So look here, where is the 5-number summary? First one, this one is the smallest data, your minimum. And then number 2, this is your Q1. Number 3, this is your median, that is your Q2. And then here is Q3. Number 3 and number 4. And then here is maximum. Okay, so how about this one? This one is outliers, if any. Okay, that's why we learn outliers first. We have to detect outlier first. If you have outliers, you can display in your box plot. If you don't have outliers, you don't have to display in your box plot. Okay, outliers, if any. So you have to detect the outlier first, because we have learned before how to detect the outliers. So the knowledge of outliers will be applied here in the box plot. If you look at here, box plot, we also have Q1, Q2 and Q3, the quartile. So your knowledge on quartiles is very important. So let's summarize a little bit. So before that, okay, box plot is a graphical 5-number summaries. So first one is minimum value, second one is Q1, third one is Q2, fourth one is Q3, and 5 here is maximum value. Okay, box plot can be horizontal and can be vertical. Alright, so where is the 5-number? Here. Here will be your minimum value. This one is Q1, this one is Q2, this one is Q3, and this one is maximum. And if any outliers, you have to put here, if any. If don't have, you don't have to put. Right, the same goes to the vertical box plot. So you must have this one. 5 number summaries, and your box plot will look like this for horizontal. For vertical will look like this. So this one is maximum, this one is minimum, Q1, Q2 and Q3. Okay, you will find box plot. If you read many journal paper, they will use box plot to summarize their data, to display their data. Alright, how to draw the box plot? Can we just draw the box plot? No, we have the procedure. Okay, so how to draw the box plot? We have these procedures for constructing a box plot. There are 1, 2, 3, 4, 5, 6 steps. So what are the first steps? First, arrange the data in ascending order. So you must arrange your data in ascending order from smallest to largest. So always sort your data. Step number 2, find Q1, Q2 and Q3. So please, your Q1, Q2, Q3 knowledge is very important. Step number 3, identify outliers. So we have learned before how to identify outliers. You have to calculate your lower limit and you have to calculate your upper limit. Is there any data that beyond your lower limit and upper limit? So if there is, so there is an outlier. Jika tiada, tiada outlier. So detect your outlier first, because outlier is very important. Okay, so the next step, step number 4, draw a scale for the data on the x-axis. So you will have the scale on the x-axis. So like here you put 5, 10, 15, 20 or 25. It depends on your data. Next, step number 5, locate the minimum value Q1, Q2, Q3 and maximum and outliers. So just now you have calculate your Q1, Q2, Q3 and then you put it into the scale here. Okay, and then number 6, draw a box around Q1, Q2, Q3, vertical line through Q2 and connect the upper and lower value. Okay, so for example, so I'll give you one example. Okay, minimum is equals to 2, Q1 is equals to 4, Q2 is equals to 6, Q3 is equals to 10 and maximum is equals to 15. So you have this 5 number summary. You want to draw the box plot. Okay, first you must draw the scale. Let's say I use scale 2. So 2, 4, 6, 8, 10, 12, 14, 16. Okay, and then you locate here. Right? Minimum is 2. So here, minimum. And then maximum is 15. So 15 around here. So here is maximum. And then Q1 is 4. So 4, Q1 here is 4. So you draw a line. You put Q1. And then Q2 is 6. So here is 6. So you put Q2. And then Q3 is 10. So put a line here. Q3. Okay, so you have 3 lines, Q1, Q2, Q3, and then you draw a box here. Then you will have your box. So how about the whiskers? You connect this one to the maximum and you connect this one to the minimum. So there you go, your box and plot. So this is the box and you have the whiskers. How about I detect the outliers? And my outliers is 30. So you can put here outliers. It is beyond of the boundary. Okay, so this is how you want to draw the box plot. This is example only. Okay, alright. So the example I showed to you just now, I follow this procedure. I skip on the part of outliers. Alright, so let's move on. This is an example, okay? A company that sells mail order phones interested to study the typical weekly sales for the inventory. So we talk about the sales for the inventory planning. The company has randomly selected 10 weekly sales from the last year record and obtained the data as shown below. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 data. So n is equals to 10. Construct a box plot for the data above, then give comment. So if you want to construct a box plot, first you must have your minimum value. So what is the minimum value here? The smallest data here is 108. And step number 2, find Q1. So this is the step to find Q1. Q1 is 1 to 2. And then step number 3, find Q2. So this is find Q2. Q2 here is 1, 2, 4. And then step number 4, find Q3. So this is how we find Q3. Q3 is 1, 2, 8. And step number 5, your largest data maximum number here is 1, 4, 7. So you have all the info. Now we want to draw. So you summarize your information in this table. Okay, the minimum value just now is 1, 5, first quartile 1, 2, 2, median 1, 2, 4, third quartile Q3 1, 2, 8, maximum is 1, 3, 1. Okay, so if you notice here, why the minimum is 115 not 108? Why? Because 108 is outlier. So if you notice here, we determine outlier. So the lower limit is 113. Lower limit is 113 and the upper limit is 137. So if you look at here, 113 and 113 and 137. Here is lower limit, here is upper limit. So look at our data here. Is there any data less than 113? Yes, 108 is less than 113. So this 108 will be the outlier. So because of that, you cannot have this minimum value 108. It will become 115 because 108 is outlier. So that's why here the minimum is 115 because 108 is outlier. The same goes to your 147. 147 here is outlier. Why? Because 147 is greater than your upper limit. So this one will be your new maximum. Okay, so how to draw? So your box plot will look like this. This one. You have the scale here and then you have the box. Okay, this one is another example. Parallel box plot. What does it mean by parallel box plot? Parallel box plot means that in one scale you will have two box plot. Okay, box plot A and box plot B. So this is does it mean by parallel box plot. Two box plot in the same axis. Two box plot in the same axis. Okay, so you have town area and you have rural area. So from the town area and rural area, you have this table. So town area, rural area. Find minimum for both. Find Q1, find Q2, find Q3, find maximum and detect the outliers. Okay, after you have all this information, you put into the same axis. So you label it. The first one is rural, the second one is town area. So this is does it mean by parallel box plot. You have two box plot in one axis. So make sure you label your box plot. So if you look at here, you still have minimum, Q1, Q2, Q3 and maximum. 5 number summary. Okay, from the box plot, we can also determine the shape of the distribution. So if you remember, we have three shapes: symmetrical, skewed to the right, and skewed to the left. Other than we determine through mode, median, and mean, we can also determine the shape using shape of the box plot. So look at your box plot. If your box plot median, so median is Q1, so median is here. If the median is near the center of the box, if your median is at the center, your box plot is asymmetrical, right? So if your Q2 median falls to the left, it is a right skewed. Okay, so if your median Q2 falls to the right, it will be left skewed. Okay, so you have to remember these three shape of distribution. It is determined using the median, location of the median. So I repeat again, if median at the center, it is symmetrical. If median towards to the left, it is right skewed. If median towards to the right, it is a left skewed. Okay. So this one is for the approximately symmetric. So let's try to do exercise. 1.4.2 number 1. Plot the box plot for following data. So how many data we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10. N is equals to 10. So in drawing your box plot, first you must sort your data. So I have sorted my data already. And step number 2, find the minimum value. So the minimum value here is 3.2. Okay, and the maximum is 11.9 here. Okay, next, find Q1. Q1 is equals to XC, where the C is I times N divided by 4. So X 2.5, it will become X3. X3 is equals to 4.5. So Q2 is equals to X2 times 10 divided by 4. So you will get X5. So because of 5 is a whole number, so use the formula X5 plus X6 divided by 2. So here you will get 5.7 plus 5.9 divided by 2. So Q2 is equals to 5.8. And then Q3 is equals to X3 times 10 divided by 4. So you will get X7.5. So X7.5 is a whole number. It's not a whole number. So X8. X8 data number 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8. So now we have done. You have your minimum value, maximum value, Q1, Q2, Q3. And then find the outlier. In order for you to find the outlier, find the lower limit. Lower limit formula is Q1 minus 1.5, Q3 minus Q1. So our Q1 is 4.5 minus 1.5. Q3 is 8 minus 4.5. So your lower limit will be negative 0.75. Okay, upper limit is Q3 plus 1.5, Q3 minus Q1. So Q3 is 8 plus 1.5, 8 minus 4.5. So here you will get 13.25. So is there any outlier? Is there any outlier? So you look at your data here. Is there any data less than negative 0.75? No. Is there any data greater than 13.25? No. So no outlier. Okay, so now we want to draw our box plot. So abaikan this one, ignore this one. So from this one you have minimum, maximum. So minimum just now is 3.2 and maximum just now is 11.9. Oh, sorry. Minimum is 3.2, maximum is 11.9. Q1 is 4.5. Q2 is 5.8. Q3 is 8. Okay, now we want to draw. So draw a scale. So it looks like this. Okay, again. Okay, draw a line. And then I will put the scale for 6, 8, 10, 12, 14. Okay, minimum is 3.2. So 3.2 is around here. So this one is minimum. Maximum is 11.9. So around here is your maximum. And then Q1 is 4.5. So 4.5 is around here. This one is Q1. Q2 is 5.8. 5.8 is around here. Q2. And then Q3 is 8. Q3. Then you draw a box. And then you draw the whiskers. Then finish your box plot. So this is your box plot will look like. Okay, based on this box plot, what is the shape of this data? Okay, look at the Q2 here. This Q2 towards to the left. Because of towards to the left, so the answer is right skewed. Okay. B, draw the box plot for this data. So if you count the number of data, sample size and equals to 10. So the first step, you must sort your data. So I have sorted my data already. So step number 2, find the minimum value. So the minimum value is 5.8 and the maximum value is 28.1. Okay, then find Q1 is equals to, so I go very fast for the quartiles because I think you can find the quartile very fast already now. So please try to do more exercise. X1 times 10 divided by 4, you will get X 2.5. So because of 2.5 is not a whole number, you have to round it up to the next whole number. It becomes X3. X3, data number 3 is 6.8. Okay, Q2 is X2 times 10 divided by 4. So you will get X5. So because of 5 is a whole number, you have to use the formula X5 plus X6 divided by 2. Data number 5 plus data number 6 divided by 2. 8.2 plus 9.7 divided by 2. Here you will get 8.95. And then Q3 is equals to X3 times 10 divided by 4. So you will get X 7.5. Because of 7.5 is not a whole number, round it up will become X8. X8, data number 8 is 14.7. Okay, next step, find your lower limit. So Q1, so lower limit is Q1 6.8 minus 1.5, Q3 minus Q1. So here if you calculate, you will get negative 5.05. And then the upper limit is equals to Q3 14.7 plus 1.5, 14.7 minus 6.8, here you will get 26.55. So I'll go very fast here, so please calculate it correctly. So is there any outliers? So look at here, is there any data less than negative 5.05? No. Is there any data greater than 26.55? Yes. Okay, we have data greater than 26.55. So this is 28.1 greater than 26.55. Okay, so the 28 will be outlier. 28 is outlier because 28.1 is greater than 26.55. So because of that, it will affect your maximum here. So your maximum is no longer 28.5. So your new maximum will be 16.4. Right? So from this information, go to here. So summarize it. Your minimum is 5.8. Your maximum is 16.4. Q1 is 6.8. Q2 is 8.95 and Q3 is 14.7. And there is outlier, this is 28.1. So draw a scale. Draw a scale here. Why? Alright. Draw a line. And I will put 5, 10, 15, 20, 25, 30. Okay. Minimum is 5.8. So it's around here. 5.8. This one is minimum. Maximum is 16.4. Also it's around here. The maximum. And Q1 is 6.8. So I think the Q1 is here. Q2 8.95. So around here. Q2 and Q3 is 14.7. So around here. So you draw a box and then you draw the whiskers. And don't forget, we have outliers 28. So around here is your outlier. Okay, done your box plot. So please draw your box plot nicely. Okay, don't follow me. I don't have the ruler here, so I have just sketched. So make sure you draw your box plot clearly using ruler. So what is the shape here? What is the shape? So you look at Q2 towards to the left is also a right skewed. Right, so please try another exercise. Alright guys, as mentioned earlier, we can have more than one box plot in the same axis. So when we have more than one box plot in the same axis, for example like this, one box plot, two box plot, three box plot, and so on. So A, B, C. So we can compare our box plot. So if the box plot for two or more data sets are graphed on the same axis like this, the distribution can be compared using center tendency and variability. So what can we compare when we have more than one box plot in the same axis? First, we can compare the average using median. Second, we can compare the variability using IQR. Okay, so average using median, variability using IQR equals to Q3 minus Q1. So always find the smallest IQR. Okay, so look at the example. So the following table represents sample of teachers in two schools. So you have school A and school B. Okay, and then they given for you Q1, Q2 and Q3 for school B, and there is no outlier. So draw box plot for both schools in the same axis. Then compare shape, average and variability. So first, compare shapes. 7, compare average. 8, compare variation. Okay, so what you need to do when you have more than 2 box plot is you have to find all the 5 number summaries. The minimum, Q1, Q2, Q3, maximum and outliers for both school A and school B. Alright, so when you have find out this one, and then you put it into your box plot. Okay, your box plot will look like this, school A and school B. So don't forget to label your box plot. Okay, this one is minimum, this one is maximum, minimum, maximum. So for school A there is outlier. So first, compare shape. So compare shape based on the median. So look at school A, Q2 towards to the left, so it is a right skewed. For school B, it is approximately symmetric. Okay, and then average based on the median values, so we state the average, and the other one is the variability. Variability, we compare the IQR, so you have to calculate IQR for school A and IQR for school B, and find the smallest IQR. So here, based on the IQR value, IQR school A is 9, IQR school B is 11. So because of IQR A is less than IQR B, so IQR B, school B is less variable and more consistent. Right? So I mentioned again, when you want to compare more than one box plot, first compare the shape. It is symmetric, right skewed or left skewed, and then compare the median values, and then you compare the IQR for variability. Alright, so this one, the box plot for special case when you have approximately symmetrical. So let's do exercise 1.4.3 number 2. Okay, for number 2, we have 2 data. 2 samples of 10 springs made out of the steel rod supplied by 2 different companies were compared. So you will have company A and company B. So company A, company B, give comment on the flexibility of springs. So you have to draw the box plot, okay, because here compare the distribution using box plot. Now we want to draw box plot. Okay, parallel. So you will have 2 box plot in the same axis. Okay, so what you need to do, you have company A, you have company B. Find all the 5 summary for both company. Find the minimum, Q1, Q2, Q3, maximum, and the outliers. Okay, so I give you the solution already. So follow the same step. Find the minimum, maximum, Q1, Q2, Q3, and outlier. Okay, after you get all this information, you just put your drop a box in the same axis. You can have like this, and also you can have the horizontal like this. Okay, it based on your drawing, and don't forget to label. So here, label here, this one must be Q3, this one is maximum, this one is minimum, Q1, Q2, Q3. The same goes to the company B. So we want to compare the flexibility. Flexibility, we compare using IQR. So remember, IQR is Q3 minus Q1. So IQR for company A is Q3 is company A is 8.8 minus 7.3. So 8.8 minus 7.3 is 1.5. IQR for company B is 11 minus 9.8, 1.2. So since IQR company B is less than company A, so company B is more flexible. Okay, so this is how you want to compare using IQR. Right, so try to understand and try to do more exercise on the drawings of box plot. Okay, the last subtopic in chapter 1 is 1.5 normal probability plot. So in normal probability plot, we will draw and interpret normal probability plot. So normal probability plots, the easiest way to check whether the sample is normal or not. So we will use normal probability plot. In your normal probability plot, you will have x-axis and the y-axis. So step number 1, you must sort your data in ascending order. Step number 2, you number your data. Step number 3, you calculate the probability using this formula. And step number 4, you plot PI versus XI, means that PI probability, XI is the data. Okay. If the sample points lies approximately on a straight line, the data we call it as normally distributed. For like this, data is around the line, so it is normal distributed. Okay. Other than plot manually, we can obtain it from software such as SPSS, Minitab, Excel, and etc. So you can look at here. It's approximately a straight line, so we call it as normal distribution. So look at this example manually. So first data, we have this one, original data. So step number 1, you must sort your data in ascending order. So after you sort your data, find the probability using this formula. So you will have the PI here. So PI versus X. So X is your data. Data is in the x-axis, so this one is the probability. So you just plot, and then you look at the plot. Is it approximately a straight line? If it is approximately a straight line, your data is normally distributed. Okay, so you can try on the exercises. So that's all for chapter 1.